Hello, this is a demonstration of a MEI problem involving the addition of probability using Venn diagrams. This sort of question, we've got a population of plants in this case, but it could be students or something of that. So it could be a survey, it could be a sample of a population. And most definitely in these cases there's no certainty of independence of these activities. This is real life, something's probably happening, there's some sort of correlation. So all we can do is use addition of probability from within this Venn diagram as the only reliable thing to do. Just bear in mind then that these questions are going to ask us for probabilities, and they rely on the fact that if we was like dipping for a red ball or blue ball out of a bag, the chance of picking any particular individual plant or person, they're all equally likely. So our probabilities are just going to be fractions. We'll come on to that in a sec. Okay, as ever, let's read the question. Whitefly, blight and mosaic virus are 3 problems which can affect tomato plants. 100 tomato plants are examined, so that's our population for this case. The number of plants with each type, number of plants with each type of problem are shown in the Venn diagram. 47 of the plants have none of the problems. Yep, so there's our 47. But here they've populated the whole of our Venn diagram for us. We've got our 3 circles, they represent the 3 sets that we're looking at here, whether they've got whitefly, blight or mosaic virus. And they've then split the individual plants up into what combination of the lot. So thank you very much to the examiner for doing that. Okay, let's have a look at the first question then. One of the 100 plants is selected at random. Okay, so that brings us back to this idea that they're all equally likely. It's something out of 100. Find the probability that this plant has at most, let's go with the first one, A, one of the problems, and B is going to be exactly 2 of the problems. So here we are, we've got 2 different examples of probability they're asking us to look for. I really advise at this point that you draw a diagram and make sure you've clearly understood what the criteria are, because that's going to decide what we're selecting. So let's just extend the page and draw ourselves a diagram. So here's our diagram, and the criteria we've got being given for part A is at most 1. Worth thinking about that and convincing yourself exactly what that criteria means. It means at most means it could be 0 or 1. So that's our list, yeah? Now we can go into our diagram and we can start sketching the areas that would fit. Well, the whole of the outside would fit the 0. Happy enough with that. That's the first part, which is our 1 area. Well, it will be these outer sections of the sets. So we went into where they intersect, we'd have 2 or 3. So here we are, we've got our areas, and if we go back further up, our areas where the relevant ones we're interested in here are populated with, there were 47 marked here in the yellow on the outside, 28 whitefly only, 3 B only and 5 M only. So our total therefore of plants that have at most 1 is 47 plus 28 plus 3 plus 5, and we're interested in that number, so that's totals 83 out of a total population here of 100. So 83 is effectively, they're all equally likely the probability is 83 out of 100 that we will get pick a plant which has at most one of the problems. So that will be, and in decimals that's 0.083, sorry, 0.830. Apologies. Okay, let's just draw the diagram for the second question, part of the question. So here's our diagram, and in this part of the question they're asking us what's the probability of selecting a plant with exactly two of the problems. So let's pick out our areas with exactly two. Well, we have to have an intersection of two. So for example, up here in the middle we've got the intersection where they've got whitefly and blight, but we can't, because it says exactly two, we can't also have the mosaic. So the central section there, the intersection of all three, is not in the, doesn't fit our criteria. But clearly the other two areas, whitefly and mosaic, or blight and mosaic, also fit the criteria. So now we just need the numbers to go in there. And the populations I've now marked up in yellow of those intersection areas are 10 plus 2 plus 1. So 13 plants fit our criteria out of a total of 100. And as they're all equally likely to be selected, that's a decimal of 0.130. Usually in MEI, you probably want to be quoting to 4 decimal places. But given these are quite short decimals, we shouldn't need to worry too much for this question. Okay, so that was pretty straightforward. Now let's go up and have a look at our final part of the question, part 2. There are 3 of the 100 plants are selected at random. Find the probability that all of them have at least one problem. Now, there's 2 parts to this question. First one, if we cut it up into, make it into smaller, simpler chunks, is that they've asked us to find the probability that a plant has at least one of the problems. But also we're selecting, the second part is that we're selecting 3 plants. So once we've selected one plant, there'll be only 99 plants left, and then there'll only be 98 for the third selection. So we've got to correct for that. So let's draw a diagram. So here's our diagram, and our criteria for Roman 2 is to have at least one problem. Well, everything inside these circles has one or more of the problems, because they've either got one problem, 2 problems, or 3 problems. The area on the outside does not have the problem. So we've got 2 routes through this question. We could either add up all the numbers inside, or we could look at the complementary probability quite quickly, and because we can see that there are 47 plants outside of the circles because they've got no problems. So that means that all the rest of the plants do have a problem. So that would be 100 minus our 47 would mean that 53 plants out of the 100 have the problem. So that's our probability when we take our first plant, isn't it? If we have our first plant, we're going to have that probability. Now, what about our second plant? Well, when we get to our second plant, we've taken one of the plants that has the problem. So we've now, there's only 52 plants left with at least one problem. But that's out of 99 plants that remain. So that's the probability of our second pick. And then we get our third pick. Well, now we've only got 51 plants left with a problem out of 98. So that's the probability of picking a plant with a problem on our third pick. So what's our overall probability here? That we select three plants that all have at least. Well, to do that, now we are going to, in the world, being able to multiply our probabilities, because each of these picks is a separate and independent pick. So we can now multiply our probabilities. So we've got a 53 out of 100 probability of picking the first, that it's got a problem. 52 out of 99 for our second pick, and 51 out of 98 for our third pick. That gives us combined, excuse me, I've written this down because I'm not going to be able, if I got a calculator out and we multiplied those together, we'd have 14056 on the top, 970200 on the bottom. Gives us a probability of 0.145 in decimals to 3 decimal places. So there you have it. Not a particularly difficult problem. How many marks did we get for that? We got 6 marks for that, and that was fairly straightforward for us. As ever, here's my little summary for you to think about when you're doing these questions. Firstly, make sure you select the right regions on the Venn diagram. It's worth checking out the criteria very carefully, particularly when looking for the words, keywords like exact or at most or at least, so that you can be clear what they're choosing for you. Definitely recommend shading in the area that's of relevance to you. You can then pick out the numbers quite quickly from the Venn diagram that you're interested in sum them up. And the probability is that effectively the fraction, it's a number of potential items in the selection over the total number in the population. Yeah, so it's 10 out of 100, therefore it's 0.1 as a decimal, 1/10 as a fraction. And do watch out if they give you a question like this one where effectively you're doing a pick. So it's a bit like the balls in a bag, you're selecting without replacement, and therefore your population total is reducing each time you make a selection, and you just need to make correction for that. So hope that's useful, and best of luck.